So up to now, we have seen about a design of dry weather flow and wet weather flow, that is estimation of dry weather flow and wet weather flow, and we have seen the various formulas for that. Okay, now we are going to see in this lecture about design of sewers. So give the heading design of sewers. So what are sewers? Sewers are the open channels. Sewers are the open channels which are used for the conveyance of sewage. So what do we mean by open channel? So in fluid mechanics, there is a separate unit for this open channel flow. So open channel, if you just see that one example, so the canal is an example of an, or we say it a channel also. So canal or channel, these are the example of open channels. So if we take a trapezoidal canal, so the cross section looks like this. Okay, so this is the cross section, and through this water flows. Now in this case, instead of water, from this what will flow? Sewage will flow. But if you just see it carefully, then this is open to atmosphere, and this sewage consists of very harmful materials. Okay, so it is very harmful. So as it is harmful, we generally prefer not to keep it open. Now the another example of open channel flow is, if you take example of an pipe. So if the pipe is running full, okay, that means if this is circular pipe, this is circular pipe, and if it is running full, that means it is completely filled with water. So if it is completely filled of water, then this is not called as open channel flow. Okay, then it is a pipe flow. But however, if it is incomplete, that means let's say it is 75% completed, then this also comes under the category of open channel flow. So in open channel flow, the major flow of water or flow of liquid, it is due to gravity. It is not due to pressure. Okay, so in this case, as it is not completely filled, so the water or sewage which will be flowing through this, it will be flowing under the influence of gravity. So while designing the sewers, that is for the design of these open channels, we are preferring the pipe cross section. Now to design this, we will be needing two things. First one is the cross section of the pipe, cross section of pipe, and second one is the bed slope. Now what is the meaning of bed slope? So if you see this pipe in horizontal direction, so this is a pipe. Okay, now let's say it is laid on the ground. So the slope of this pipe is also very important, because it should be aligned in such a way that this sewage flows automatically and it does not consolidate at any point. So it should be keep on flowing. It should not wait, or it should not block anywhere in the pipe. So the slope should be given in such a way. Now this slope is called as bed slope. Okay. Now there are two things here that you should pay attention. See, in sewers, we know that there are suspended particles and other harmful particles, or we can say impurities, which are present. Now these impurities should not settle in the sewers. These impurities should not settle in the sewer. Okay, so the velocity with which the sewage should be flowing. Once again, I am repeating, the velocity with which the sewage water or the sewage is flowing, it should be such that there is no settlement of these particles. Such velocity is called as self-cleansing velocity. Okay, so just you can imagine that there is a sewage which is flowing through this pipe. Now the velocity of this sewage should be such that the particles should not settle. Okay, the particles present in the sewage, they should not settle. There should not be any settlement of particles. It should be self cleaning the sewer. And the second velocity is the maximum velocity, that is, the velocity should not be very high, so that these outer pipelines which we are keeping, these conduits, this should be damaged. Okay, so required velocity should be somewhere between the maximum velocity and the self cleansing velocity. Now let's write down these points quickly. So sewers are designed as open channels, as open channels. So sewage is carried by sewers under the action of gravity, under the action of gravity. Okay, now sewer design includes, sewer design includes, the first one is fixing the cross section of sewer, fixing the cross section of sewer, and second one is the fixing the slope of the sewer, fixing the slope of the sewer. So we have seen that it is designed as an open channels. Okay, so formula used in open channel, the same formulas we are using it in the design of sewers. So formulas or formula used in open channel, are used in design of sewer, are used in design of sewer. So write down these two formulas. The first and the most important is continuity equation. Continuity equation. So Q is equal to area into velocity. And second one is called as Manning's equation. Manning's equation. And in this case, V is equal to 1 by N R to the power 2 by 3 S to the power 1 by 2. So these formulas, these are there already in the fluid mechanics. Okay, so these are taken directly from there, this continuity equation and Manning's equation. Now the remaining part that we'll see in the next video, that is about the design velocity. So we have already discussed the concept that the velocity should be between the self cleansing velocity and the maximum velocity.